Imagine a dark sky, stars twinkle above. Unseen, a predator glides through the night. It's a stealth aircraft, a marvel of modern engineering. These aircraft are ghosts, invisible to radar and the naked eye. They are the embodiment of surprise, striking fear into the heart of the enemy. Stealth technology has revolutionized aerial warfare. It allows us to dominate the skies. From the shadowy beginnings of the Cold War to today's advanced fighters, the evolution of stealth has been marked by innovation and determination. This essay delves into the world of stealth aircraft. We will explore their history, their technology, and their impact on the future of warfare. The seeds of stealth technology were sown during the Cold War, a period marked by intense rivalry and rapid technological advancements. The United States and the Soviet Union were locked in a tense standoff, each striving to outdo the other in military prowess. Both sides sought a technological edge, pushing the boundaries of innovation and engineering. In the early 1960s, the need for silent reconnaissance became paramount, especially for missions that required undetected surveillance. Lockheed, renowned for its innovative aircraft designs, stepped up to the challenge with a unique approach. Enter the Lockheed Y-03A, a quiet observation aircraft designed to operate with minimal noise. It was designed for a specific purpose, to observe enemy troop movements in Vietnam without being detected, providing crucial intelligence. The Y-03A was not a true stealth aircraft in the modern sense. It relied on minimizing noise to avoid detection by enemy forces. The engine was specially designed to be as quiet as possible. The propeller was chosen for its quiet operation, reducing the aircraft's acoustic footprint. The airframe was built to minimize noise reflection, further enhancing its stealth capabilities. While rudimentary by today's standards, the Y-03A proved a crucial concept in the evolution of stealth technology. It demonstrated the value of minimizing an aircraft's acoustic signature, a lesson that would inform future designs. This paved the way for future stealth technologies, influencing the development of more advanced and sophisticated stealth aircraft in the years to come. Stealth technology is not about making an aircraft invisible. It's about making it incredibly difficult to detect. Think of it as camouflage for the skies. This is achieved by minimizing an aircraft's radar cross-section and infrared signature. Radar works by emitting radio waves. These waves bounce off objects and return to a receiver. A larger object reflects more waves, resulting in a larger radar signature. Stealth aircraft are designed to scatter these waves, reducing their radar reflection. Infrared signature refers to the heat an aircraft emits. All aircraft engines generate heat. Stealth aircraft use special materials and design techniques to minimize this heat signature. The quest for stealth continued after the Y-03A, pushing the boundaries of aviation technology. Lockheed's Skunk Works, a division known for its top-secret projects, was at the forefront of this innovation, constantly experimenting and refining their designs. Two groundbreaking aircraft emerged from this era, the SR-71 Blackbird and the HAV Blue, each representing a leap forward in stealth technology. The SR-71 Blackbird was a marvel of engineering, capable of reaching speeds and altitudes that were unprecedented at the time. It was specifically designed for high-altitude, high-speed reconnaissance missions, gathering critical intelligence while evading enemy radar. While not truly stealthy by modern standards, it incorporated radar-absorbent materials and a streamlined design to reduce its radar signature, making it harder to detect. The HAV Blue was a different beast altogether, representing a bold new approach to stealth. It was a technology demonstrator designed to test the very principles of stealth, pushing the envelope of what was possible. The HAV Blue's unconventional, faceted design was optimized to scatter radar waves, making it nearly invisible to radar detection. It was a radical departure from traditional aircraft design, showcasing a new direction in aviation technology. The HAV Blue proved that stealth was achievable, demonstrating the effectiveness of its innovative design. It laid the essential groundwork for the world's first true stealth aircraft, the F-117A Nighthawk, which would revolutionize aerial combat and reconnaissance. The B-2 Spirit ghost in the machine. While the Nighthawk focused on tactical bombing, the B-2 Spirit took stealth to a strategic level. This flying wing bomber, developed by Northrop Grumman, was designed to penetrate deep into enemy territory and deliver massive payloads. The B-2 Spirit's design is both elegant and menacing. Its blended flying wing configuration provides inherent stealth capabilities. The lack of vertical stabilizers minimizes radar reflections. The aircraft's smooth, continuous surface further reduces its radar signature. The B-2 Spirit's stealth capabilities are enhanced by its internal weapons bay and sophisticated coating. It can carry both conventional and nuclear weapons, making it a formidable deterrent. The B-2 Spirit remains a cornerstone of the United States strategic bomber force. Section 6. Raptors and Lightnings. Dominating the skies. The F-22 Raptor and F-35 Lightning II represent the cutting edge of stealth fighter technology. These fifth-generation aircraft combine stealth with advanced avionics and maneuverability. The F-22 Raptor, developed by Lockheed Martin, is an air superiority fighter. It is designed to outmaneuver and defeat any enemy aircraft. The Raptor's stealth capabilities are derived from its carefully sculpted shape, internal weapons bays, and radar-absorbent materials. The F-35 Lightning II, also developed by Lockheed Martin, is a multi-role fighter. It is designed for air-to-air combat, ground attack, and electronic warfare. The Lightning II's stealth capabilities are crucial for its survivability in contested airspace. Section 7. The Cat and Mouse Game. Counter-stealth measures. The development of stealth technology has spurred a counter-movement counter-stealth technology. As stealth aircraft become more sophisticated, so too do the systems designed to detect them. Radar technology has evolved to counter-stealth. Low-frequency radar, for example, is believed to be more effective at detecting stealth aircraft. These radars emit longer wavelengths that can potentially see around the sharp edges of stealth design. Other counter-stealth measures include infrared search and track systems, or IRSTs, and passive radar systems. IRSTs detect the heat emitted by aircraft, while passive radar systems rely on analyzing reflections from civilian radio and television broadcasts. Section 8. The B-21 Raider and beyond. The future of stealth technology is shrouded in secrecy. However, one thing is certain: the game of cat and mouse between stealth and counter-stealth will continue. The B-21 Raider, the United States' next-generation bomber, embodies this evolution. The B-21 Raider, developed by Northrop Grumman, is shrouded in secrecy. Details about its design and capabilities are scarce. However, it is expected to incorporate advanced stealth features that will make it even more difficult to detect than its predecessors. Future stealth aircraft may employ even more exotic technologies. Directed energy weapons, hypersonic flight, and artificial intelligence could all play a role in the evolution of stealth. Section 9. The future of warfare. Stealth technology has fundamentally changed the nature of aerial warfare, revolutionizing how air battles are fought and won. It has shifted the balance of power, giving stealth-capable nations a significant advantage in contested airspace, making traditional radar systems almost obsolete. From the silent skies of Vietnam to the cutting-edge fighters of today, stealth technology has come a long way, evolving through decades of innovation and conflict. The future of stealth is full of possibilities, with advancements in materials, design, and electronic warfare. As technology advances, we can expect even more sophisticated stealth aircraft capable of unprecedented feats of evasion and precision. These aircraft will be designed to evade detection, deliver precision strikes, and dominate the skies of the 21st century, ensuring air superiority. The quest for stealth is a testament to human ingenuity, showcasing our ability to push the boundaries of what is possible. It is a story of innovation, determination, and the relentless pursuit of technological superiority, driven by the need to stay ahead in an ever-evolving battlefield. As we look to the future of warfare, one thing is certain: stealth technology will continue to play a pivotal role in shaping the battle space, defining the strategies and outcomes of future conflicts. Thanks for watching. Please like, share, and subscribe for more.